Hello students, today's video is on area under the curves or application of integrals with super shortcuts. You definitely find these shortcuts very useful as applications of these are frequently asked in previous year's entrance exams. Now the area of region bounded by y square is equal to 4ax parabola and y is equal to mx is just we have to use this shortcut to find the area, and that is 8 by 3 a square by m cube. We get a from parabola and m is what the slope of the line, and we just substitute the values here and we get area, and obviously that is mod. Area is always positive. When we get the area of region bounded by the parabola x square is equal to 4by and y is equal to mx, then in that case we have to just replace this a by b and 1 by m by n. So my area under this condition is 8 by 3 b square into m cube. These again we get b from parabola and m is what slope of the line, and these two lines are passing through origin. But if instead of that, if we get the area of region bounded by y square is equal to 4ax type parabola and y is equal to mx plus c, then my answer is 72 a square by m cube square units. Similarly, if I get the area of region bounded by x square is equal to 4by and y is equal to mx plus c type of line, then my answer in this case, again replace a by b and replace 1 by m. So here I get 72 b square into m cube square units. The next shortcut is the area of region bounded by two parabolas, those are y square is equal, sorry, the area of region bounded by a parabola y square is equal to 4ax and x is equal to c, a line parallel to y axis where c and a both are positive. Then under this condition, area is 8c root ac upon 3, where a we get from parabola and c from the line. Next, the area of region bounded by two types of parabola, that is y square is equal to 4ax and x square is equal to 4by, is 16 by 3 into ab square units. Again, a from this parabola and b from the second parabola. Now here are the applications. As we can see that y square is equal to 4ax type parabola is this type of parabola passing through origin, and y is equal to mx is a line which passes through origin. So this is what the diagram of y is equal to mx, and this is what y square is equal to 4ax parabola. Again here we apply the shortcut, that is 8 by 3 a square by m cube. Now the area bounded by the parabola y square is equal to 4 lambda x and the line y is equal to lambda x is 1 by 9. So what we do here, this question was asked on 2019 12th April J exam. Now if we compare this parabola with y square is equal to 4ax and this line with y is equal to mx, then in place of 4a we have 4 lambda, so a is here lambda, and in place of m we have lambda. As we know that area enclosed by this parabola and the line passing through origin is 8 by 3 a square by m cube, and that is given to us 1 by 9. So we just substitute the values. Here I get 8 by 3, I put a is equal to lambda, so this is lambda square, and m by lambda again, so this is lambda cube, 1 by 9. On further solving, what I get, 8 upon lambda is equal to 1 by 3, and Hence we get lambda is equal to 24 as our answer. So there is no need to use integration here. Just substitute the values in the derive in shortcut. Now, so my answer is C option. Now this is my next question. The area of region bounded by y square is equal to 4ax parabola, and the line which is not passing through origin, that is y is equal to mx plus c, is 72 a square by m cube. So here my parabola is y square is equal to 2x, and my line is x equal to y plus 4, or y is equal to x minus 4. Now if I compare this parabola with y square is equal to 4ax, then 4a is here 2 and a is here 1 by 2. And if I compare this with y is equal to mx plus c, so m is here 1. That is the coefficient of x. But if I draw the diagram of this line, then in intercept form, if I convert this line into intercept form, I get 2 points, one on x-axis, another on y-axis. Then my answer is x by 4 plus y upon minus 4 equal to 0. That is 4, 0, a line joining 4, 0 and 0 minus 4. So diagram of line is like this. A line joining the point minus 0 minus 4 and 4, 0 is somewhat like this. If I produce this parabola, so this is my required area. But by just substituting the value in the shortcut, that is a is equal to 72 a square by m cube. So here I put a is equal to 1 by 2, therefore 1 by 2, and m is here 1. So what I get, 1 into 1 into 1. So my answer is 18 square units. So just by substituting the values in the shortcut, I get D as my option. This was asked on again 2019 JE exam, 9th of April. This question was asked on 2nd September 2020, second shift JE exam. Again here we use our shortcut. The line is here y is equal to alpha, which bisects the region bounded by the parabola, that is x square is equal to y, and the line y is equal to 2x. If I compare x square with x square is equal to 4by, then 4b is here 1, so b is here 1 by 4. And if I compare this line with y is equal to mx, so my m is here 2. But since in this question it's given that y is equal to alpha bisect the area bounded, and y is equal to alpha, we know that is a line parallel to x-axis, somewhat like this. So this is my line y is equal to alpha. So this is my line parallel to y is equal to alpha. And y is equal to 2x is a line which passes through origin. So diagram of this line is somewhat like this. And according to the question, that this line bisect this whole region into two equal halves. Bisect means that means just divide this whole, the area enclosed between this parabola and the line passing through origin is this, and this line bisect this region. So that means we take one half as this. But according to our formula, the area bounded by this parabola and the line, and my shortcut was 8 by 3 b square into m cube. So here I replace b by 1 by 4 and m by 2. So what I get from here, this comes out to be 4 by 3. And this is equal to 2 times area of OAB. Suppose this is my A and as well. Like using application of integrals, we are moving along y-axis. So what we do, we just equate this by 2 times and we are moving in along y-axis from 0 to alpha. So I can replace this by 0 to alpha, and if I take my rectangle, the small rectangle this, which is moving along y-axis, so my formula is here x2 minus x1 dy, as if I take this point as x1 y1 and this corresponding point on here as x2 y1, as this is a line parallel to x-axis, the y coordinate remains same, and this is what the area of this small shaded triangle, that is length into breadth. Length is here x2 minus x1 and breadth is a very small change along y, that is dy. Now since x2 is on the parabola, so from parabola the equation of parabola was x square is equal to 4by. So y x2 from my parabola was x square is equal to y. So x2 is on the parabola, so my value of x is here root of y. And since x1 is on the line and line is y is equal to 2x, that means x is equal to y by 2. So my x1 comes out to be here minus of y by 2 dy. Here I put 4 by 3 and this comes out to be 2 by 3, and integration of root y is y 3 by 2 into 2 by 3, and here I get y square by 4, 0 to alpha. This is 2 by 3, 2 by 3 alpha to the power 3 by 2 minus alpha square by 4 minus of 0. On further solving I get 2 by 3, and if my LCM is here 12, so here I get 8 alpha 3 by 2 minus of 3 alpha square. On further solving I get 8 is equal to 8 alpha 3 by 2 minus 3 of alpha. So my desired option is here option A, or first option is the correct answer. As I already told you, the area of the region bounded by y square is equal to 4ax and x equal to c, where c and a both are positive, is 8c root ac by 3. And in this question, which was asked on 8th April 2019 J exam, S alpha is what x comma y, said that x y square is less than equal to x and x is in between 0 to alpha, and a alpha is the area of the region S alpha. If for lambda which lies in between 0 to 4, a lambda is to a4 is equal to 2 is to 5, then lambda equals to. Since parabola is here y square is equal to x, so this is comparable to y square is equal to 4ax type, where 4a is equal to 1, so a is equal to 1 by 4. And line here given as one is x equal to 0, that is y axis. Another is x equal to alpha, which is, if in this question x equal to alpha is given to us, and I just compare this with x equal to c, so c is here alpha, and line x equal to alpha is a line parallel to y-axis. So this is my x equal to alpha. Since we have to find the area enclosed between x equal to 0, x equal to c, x equal to alpha, and y square is equal to 4x. So this whole region is the desired region. And since this parabola is symmetrical about x-axis, so we just replace this by 2 times area of the shaded part. Now, according to our formula, area is 8 by 3 c root of AC. So in place of c, I just substitute alpha, and in place of a, I just substitute 1 by 4. So my area is, and since this is in terms of alpha, so this is written as a alpha, alpha, alpha into 1 by 4. On further solving, what I get, 8 by 3, 1 by 4, root of 1 by 4 is 1 by 2, and alpha into alpha 1 by 2. So a alpha comes out to be 4 by 3 alpha to the power 3 by 2. And the given condition is here, a lambda is to a4 is to 4. So that means a lambda upon a4 is 2 by 5. If a alpha is this, then a lambda would be 4 by 3 lambda 3 by 2, and a of 4 is just replace alpha by 4. Now, if I substitute these values in this equation, so what I get, in numerator I get 4 by 3 lambda 3 by 2, and in denominator I get 4 by 3. 4 to the power 3 by 2 is equal to 2 by 5. On further solving, what I get, this is lambda by 4 whole to the power 3 by 2, squaring, what I get, lambda by 4 whole to the power 3, and here I get 4 upon 25, and then taking cube root, here I get lambda by 4, and here I get 4 by 25 to the power 3 by 2, and on further solving I get lambda is equal to 4 into 4 by 25 whole to the power 3 by 2 as my value of lambda. So my desired option is here, option C, that is 4 into 4 by 25 whole to the power 1 by 3. If I took cube root, so I just have to replace this by 1 by 3 and 1 by 3, right? Another shortcut was the area bounded by y square is equal to 4x, that means this type parabola, and x square is equal to 4by, that means this type of parabola. If we use integration, then we get this step, but we just substitute the value of a and b in the shortcut, as the area bounded by y square is equal to 4x and x square is equal to 4 by y is 16ab by 3. So this question was asked on 10th January 2019 J exam. The area enclosed between the curve x y square, y is equal to k x square, or x square is equal to 1 by ky, which is comparable to x square is equal to 4by, where 4b is 1 by k and b is 1 by 4k. So we just get the value of b. Another parabola is given here, x is equal to ky square, that is x is equal to ky square, or y square is equal to 1 by kx, is comparable to y square is equal to 4ax type parabola. So 4a is here 1 by k and a is here 1 by 4k, right? and our shortcut is the area enclosed here is A, and that is 16 AB by 3 given to us 1 square unit. We just substitute the value of A and B here, which is in terms of K. So 16 by 3, A is in terms of K and B is also in terms of K, and is 1 by 4K, 1 by 4K, and this. On further solving, what I get, 1 by K square is equal to 3, or 1 by 3 is equal to K square. Taking square root, I get, so my desired option is here 1 by root 3. This shortcut I had already discussed in my straight line video also. Just have a quick recap. The area enclosed by the graph mod of x plus mod of y is equal to A is 2A square unit. This gets resolved into 4 cases, that is x plus y is equal to A, and in intercept form this comes out to be x by A, y by A equal to 1, that is A0 and 0B. Another case is x plus y is equal to minus A, and here I get this in intercept form, that is x upon minus A, y upon minus A equal to 1. So minus A 0 and 0 minus another line is this. The third case is x minus y equal to A. So here I get A0 and 0 minus A as my intercept. So A0, 0 minus A, joining this, we get this line. And the fourth case is x upon minus A, y upon A, and hence we get this. And since we have to find the area of this whole quadrilateral, and from the diagram we get that these 4 triangles are congruent, as this side is common. This is what right angle, and if suppose this OB distance is A, the same distance, this distance suppose is OC is again A. So all these 4 triangles are congruent, and what we get, the area is 4 times area of triangle OAB, and that is half OA into OB, and on further solving I get 2 OA and OB, where O is my x-intercept. From the diagram we can see that O is my x-intercept and OB is my y-intercept. So my shortcut is here, whenever you get these types of 4 lines around origin with same x-intercepts, just vary in signs, and with same y-intercept, those again vary in signs, then the shortcut is here, area is always 2 times x-intercept into y-intercept. Just get one line resolved into a intercept form and get A and B from that equation and just substitute here. Same in this case, my x-intercept is A and y-intercept is again A in this particular case. So my answer is 2A square unit. But my shortcut is that 2 times x-intercept into y-intercept is the answer of this particular question. Now, this is here application. Again we get 4 cases. One is y is equal to x minus 1. After resolving this, we get y is equal to x minus 1. Another is y is equal to minus x minus 1. From the second line, that is, again we have 2 cases, y is equal to minus x plus 1 and y is equal to plus x plus 1. So we get 4 lines with x-intercept and y. Just resolve one line into intercept form. If I change this line into intercept form, this is x plus y equal to 1. My x-intercept is 1 and y-intercept is 1 here. And just we put the value in my formula, that is 2 times x-intercept into y-intercept. So my area is here 2 square units. As we can see, the desired area is 4 times area of triangle OAB, and shortcut is 2 times x-intercept into y-intercept. So answer is here 2 square units. Another application is here. We just use our shortcut. Again, this gets resolved into 4 cases. we just consider one case, and that is 2x plus 3y is equal to c, that is x upon c by 2 and y upon c by 3. This is my x-intercept and this is my y-intercept. And here area given to us 12 square units, and we have to find the value of c. So we just use our shortcut, that area is here 2 times x-intercept into y-intercept, and that is here 2 into c by 2 into c by 3, which is given to us 12. And on further solving, what we get, c square is equal to 36 and c is equal to plus minus 6. So here my value of c is option D, that is 6. Now another shortcut, as we know that the area of square x square plus y square whose center is at origin and radius r is, area is here pi r square. Similarly, area of ellipse whose equation is x square upon a square plus y square upon b square is equal to 1 is pi ab square units. This is my ellipse whose vertices are a0, this first type of ellipse where a is greater than b. So these are my vertices a0 minus a0, and this is my 0b. Ends of minor x is 0 minus b. Area of this ellipse is pi ab. If area of circle x square plus y square is equal to a square is pi a square, the area of ellipse x square by a square plus y square by b square equal to 1 is pi ab square units. This ellipse has its center at origin, but if its center gets shifted to another point, that means in this particular case we have our center as alpha beta. Center of this ellipse is alpha comma beta, but area remains same. So this is what, if center shifted to alpha beta, so ellipse reduced to x minus alpha whole square by a square plus y minus beta by beta whole square by b square is equal to 1, but my area remains same, that is pi ab. Now this question came on 2nd September 2020, shift 1, and we use our shortcut here. Area of ellipse, as we know, is pi ab. So my area is here pi ab, and we know that if we have this type of equation, so this gets resolved into 4 cases, and we derived if my x-intercept is here capital A and y-intercept is capital B, then area enclosed by these 4 lines will be pi x-intercept into y-intercept. So this is my A1 and this is my A2. And as we can see in this particular case, the area of the region outside mod of x by 2 plus mod of y by 3 equal to 1, and inside the ellipse x square by 4 y square by 9 is equal to 1. Inside of the ellipse is this whole part, and outside of this is this part. So the common area is this shaded area. So what we have to do, my desired area comes out to be, if we subtract area of these 4 lines or this quadrilateral from area of ellipse, we get the desired area. That means if we subtract this region from the area of ellipse, we get our answer. That means my required area is A1 minus A2. And according to my shortcut, A1 is pi AB and A2 is 2 times capital A and capital B. Ellipse is here x square by 4, y square by 9 equal to 1, which is comparable to x square by A square, y square by B square. So from here, A square is 4, so A is equal to 2 or plus minus 2. B square is 9, so B is here plus minus 3. So my A is 2 and my B, small b, is 3. And one of the line from these 4 cases is x by 2 plus y by 3 equal to 1. If I compare this with my line x upon capital A plus y upon capital B equal to 1, then in this case my capital A is 2 and my capital B is here 3. And according to my shortcut, if I substitute these value, what I get, replace A by 2 and B by 3. So this is pi into 2 into 3, and here I get capital A is equal to 2 and capital B is here 3. So my answer is 6 pi minus 12, or if I take 6 common, so my answer is 6 into pi minus 2 square units. So my first option is the correct option. Now here, if we have to find the area of the region bounded by the ellipse this type or maybe of this type, x square by a square plus y square by b square equal to 1, and the straight line whose endpoints are major and minor axes, that means this line is my x by a, y by b is equal to 1 given to here. As we derive that the area enclosed as we derive that area of the region bounded by the ellipse x square upon a square y square upon b square equal to 1, and mod of x upon capital A plus mod of y upon capital B equal to 1 is pi ab minus 2 times x intercept into y intercept. Here we get 4 cases from this line, but in this particular question we have an ellipse and only one line, so my area just restricted to this part. In previous case, the region bounded by ellipse and 4 lines was this. As we have discussed, the area bounded by this type of ellipse and the 4 lines represented by this equation is this. And the formula was IAB minus 2 times x intercept into y intercept. Since in this particular case, we have to find area bounded by this type of a parabola and a line whose one end is end of major and another is end of minor axis, that is the line x by a plus y by b. So according to this diagram, we just need this area, that is 1/4 of the shaded area. So just divide this area by 4, so we get desired area. That is, in this particular case, my formula comes out to be 1 by 4 pi AB minus 2 times area of 2 times x intercept into y intercept. Now, in this question, ellipse is x square by 16, y square by 9 equal to 1, which is comparable to x square by a square, y square by b square equal to 1. A is here 4 and b is here 3, and the line is here x upon 4 y upon 3 equal to 1, which is comparable to x by capital A plus y by capital B equal to 1. That means capital B is here 4 and capital A is here 4 and capital B is here 3. We just substitute values here. Here I get 1 by 4 pi into 4 into 3 minus 2 times 4 into 3. On further solving, what I get, my answer comes out to be 1 by 4 12 pi minus 24, and this is 3 pi minus 6 square unit is the correct answer. I'm sure this video helped you a lot Soon I'll be back with new video on this topic. Do like, comment and share this video and subscribe my channel Method Wise. Thank you.